So in the last video, we talked about the hardware, right? How do we choose our machines and whatnot? Now that we've got them, let's start installing stuff. So let's just get right into it. I've prepared this project over here. This is the CoreOS host install project. I've been using this as my base operating system for everything that I've been doing so far. It's been pretty stable, kind of okay, but I feel the operating system isn't that important. We leverage Kubernetes for everything, so that's the more important thing. This is just kind of a means of getting Kubernetes installed, but if you prefer a different way, sure. We do use K3s, so that's what's providing the Kubernetes cluster. There are a few flavors out there, but K3s is pretty good. And as I said, Fedora CoreOS to install this. I chose CoreOS, as I said, because I found it pretty stable. It's something that I had some previous experiences with, and it's also declarative, right? Like I can configure it through a file. I don't need to, go into a UI and kind of click buttons or use the terminal that much, like SSH into them and configure them. I can just define how it needs to look like, and then it just kind of looks like that. So to kind of get started, we'll need to clone this repository. This isn't, like, we're not going to persist anything here. So whenever I kind of work with things that don't really persist, just so they don't clutter my operating system, I just put them in the temp directory. So we can just open this up. I'm using Z as my IDE. So that's what I'm gonna open it up with. And this is basically the same repository over here. We're gonna check it out on GitLab, just because it looks nicer here than in the markdown viewer of Z. That's not that great. But we'll need to do some things, right? So we'll assign roles to each machine. So we do have two machines we need to install. One of them is going to be our controller, and the other one is going to be our worker, like our general purpose worker. So we just need to have some awareness of that. We'll get to that in a minute. We'll define the input file. So this contains the way the machine itself needs to look like. We'll generate the ignition file, and this ignition file is something that CoreOS needs in order to be configured. And then we'll just use the file and create a custom ISO, and this is the one that we'll use to install the operating system. Now, because we need to store some details of the machines, this is something that we should store locally. So in my user home, right on my Linux over here, on my user home, I'm gonna do a atHomeHub directory. And I'm also gonna do a git init for this one, just because I want all of my changes to be tracked. So as I'm updating these, I do want to see all the things that I'm updating and be able to do differences between them and whatever. I don't want this to exist in like a public repository. So that's why I'm initializing a Git repository locally. And I'm gonna open this up as well. Let me close that off. And let me just create a host file. And then in this, we're gonna keep the configuration of each one. I'm also gonna create like a README file. And this is where I'm just gonna store notes about these machines. So if I need to remember something that I've done before, I can just do this here, right? I can take note of it and remember what I've done before. Now we need to get some details from these machines. We can just like install it, right? We need to do some configuration. So for that, we need to connect to them. Just to simplify things, I am going to use PyKVM. I have a PyKVM box that's sitting on top of a box of broken AirPods, which I keep to remember myself not to buy those again. And I don't use the PyKVM connect, like it's not always connected to my like servers or machines or whatever. I just keep it around whenever I need to connect to these, just interact with them directly. That's when I use it. It's usually just plugged off and not being used. But let me just connect to this. All right. And I do have a USB stick here. This just has like a Fedora workstation installer on it. We're going to use that to boot into it and just kind of check how the machine looks like. So I'm going to power that on. And on Dell machines, you need to press F12 to get into the one-time boot menu. I already have some stuff on this, but I just want to access the live boot installer, I guess. This is like the secure boot stuff. So now we'll wait for a bit. All right. So now that we're booted into the Fedora installer, we're going to dismiss this just because we don't want to install that Fedora at least. So let's start with the disks app. So we've opened this up because we need to get some details from our disks. So what we're interested in is this device over here. I can select it, right? But for both of the drives, right? So I have the 256 gig. This is my boot disk, and this is going to be the disk that holds my personal storage. So you can see that these have different devices specified here. So this is /dev/SDA for my personal disk, and this is /dev/NVMe0N1P1. This is for my my OS. So since we're here, you can also see that we've got some partitions on it. I'm guessing I used this at some point for another kind of install of this. So I'm just going to format it, and I'm going to say overwrite existing data with zeros with no partitioning. The installer is going to take care of the partitioning and whatnot. I'm not necessarily going to wait for it to erase everything, like to fill the entire drive with zeros. The reason I'm doing this is because from my past experience, I've noticed that the CoreOS installer can like unearth former partitions. So if at some point we had some sort of partitioning on this, even if you do like the quick format, it can pull those up. So I just prefer to do this like full zero erase and just start it off on both devices while I figure the rest of the stuff out, right? We need to prepare that ISO. So while we're preparing it, this can run in the background. But with this information, let's just go back to our README over here that we're preparing. So we'll start off and say, let's just say that this is the HomeHub controller. Right, as we said, the role of this machine, the first one that we're setting is going to be the controller. So HomeHub controller, actually atHomeHub controller. And I'm going to say personal disk is /dev/SDA. And if we switch back to this, the OS disk is /dev/NVMe0N1. So OS disk is /dev/NVMe0N1. NVMe0N1. Okay. We also need to know the IP of this machine. So I do use Unify, like the unified devices and whatever. So we can see that since we plug this into the internet, right, my local network, I can see the machine showing up here. We got this IP address from DHCP. And if we go to, let me just open this to the side. Oh, that's very small. Whatever, it's fine. I can zoom in. But if we run a quick IPA command, I guess that's taking up a bit of resources. Can you open up settings? Can go in now. So if we run a quick IPA command, we'll see that this gives us the current settings, right? So it did get the IP of 192.168.69.115. And this matches with what we see in Unify over here. So what I'm going to do, I'm going to say that this is the so this can be the atHomeHub controller. And I'm going to give it a static IP address. I tried to stick outside of the range of the DHCP. So if we go to the network settings for the atHomeHub network, we can see that the DHCP range is set between 100 to 150. So because we have this range over here, I can just, pick something below it or over it. It kind of depends on you how you want to put this together. Just because these systems, I consider them kind of like critical to my home. I usually put them before. So I'm just gonna give this 69.5 and just apply the changes. I'm not gonna try to restart it now. I know that this works. I'm just gonna leave it be. And when we actually install like CoreOS, it's gonna take this IP address, right? I can say for certain that it's gonna take that. Let me just move this back into a full window because we're kind of done with Unify for now. And let me just say here as well, the IP is 192.168.69.5. I'm just noting these down in my README over here so I know about it. Now, for the input file, right, this is going to dictate how our applications or how our machines will be configured. So we're going to need to use the example controller. This is going to be this is going to be a controller. It's going to have that role. So we just use this as a starting point, and I'm going to put it in this data directory. I'm going to say input YAML and just paste this. I'm going to give it the same name that we've given it here. Just make sure you don't have like any camel case, like uppercase characters or whatever. I try to put the host name all lowercase and only dashes. That's all I use here. Nothing else, no underscores, nothing like that. We do need to configure the time zone. I'm just going to put my local time zone, which is America Toronto. I've added some details about this input file here, so you can check these if you have some questions or whatever about how to set these up. The time zone, for example, I've also given a link to where you can see all of these. I think this is just a Wikipedia link of a list of all the available time zones. One thing to note as well, if you have multi-threading, you will need to set this as well, the kernel mitigations auto only. If you don't set this, hyperthreading just gets disabled. I thought this is happening only on older CPUs because of like the Spectre and Meltdown thing, which I don't remember which CPUs it affected. But it did affect these machines of mine over here. These are my new nodes. These are like 10th gen i5. So I wasn't expecting those to suffer from this, but they did. So I did have to set this just so I see all 12 threads and not just 6 threads, right? Like you have multi-threading, so why not use it? But that's something that can be reviewed later. We have like the Kubernetes settings here, so like the K3s version to use. We do have all of these defaulted, so in theory you don't need to define the version, you don't need to define how much disk is reserved to the host operating system. But because these can change in the main project. Like let's say I'm gonna upgrade the default version from 133 to 134 of Kubernetes once that's available. You should have this in your own configuration file just so you don't just like unexpectedly get a Kubernetes upgrade if you just want to tweak something in your OS. Same with the disk reserved, we default to the same value, but I think it's beneficial to keep that in your configuration file for the same purposes, right? Like let's say later down the line we decide that this is too much and we want to lower it for all of the future installs of this project. You don't want to be impacted by this, right? Like partitioning on the disk is going to be impacted by this. And if you change this and you just like reinstall, it's going to fail because it cannot like change the partition size. So that's one. Then the authorized keys. So we don't enable SSH authentication to this through passwords. We just use keys. So we will want to generate keys. Usually you would see them in your .ssh directory from your user home. I just moved my keys into that mine folder over there, just so I don't, lose them because they grant me access to all of my other nodes. But to generate a key, you can just do SSH keygen. So let me just actually zoom back into this. So SSH keygen. If I hit enter, it's gonna tell me that's gonna generate a key pair. It's gonna ask you for a file name. You can just keep it as is, it's fine. You can also have a passphrase to these, like a password. So whenever you use them, you need to input the password to access the key, which is recommended, but I'm not gonna put it for the purposes of this video. It's gonna make it easier. So I'm just gonna hit enter, and then it generates a key. And this is like the key fingerprint and whatnot. So what we can do now, if we list the documents here, why do I keep zooming out? Oh, that's, wait, let me just move this over here. Nope, what happened? Okay. So if we just zoom in here, we see that in my .ssh directory, we now have these two keys that we didn't have before, right? When I listed this before, we just had like no host, mine, and that's about it. So this is what we're interested in, right? The .pub file. This one is a thing that you really need to keep secure. So this is not something that's going to leave your machine. If you change your machine, if you reinstall your operating system, ideally you should rekey. So you should generate a new SSH key and just kind of reinstall stuff to use that updated key. That's like the most secure way of dealing with this. The pub file, this is the one that you can actually share. I mean, don't share it with everybody, right? Don't share it with everybody, right? People don't need to know your public key, but this is something that, for example, I could just read, right? So I can do a cut on it. It's going to show up. It has like this format, and this is what we're going to set in our authorized keys over here. Over here. Usually the middle mouse button does pasting on Linux, and there we go. So that's our public key sorted out. So that's what's gonna allow us to SSH into this and like get the configurations files and what we need from it. We're not gonna do a lot of that. Like we're not gonna SSH to these over and over and over. We're just gonna do it once and hopefully never again. But we'll get into that later. And now I just need to make sure that my personal disk is set here correctly. So what I do is I name this personal because it holds my personal data. So I just give it the name of personal so it makes sense. And mention the device where this disk is located. So dev SDA matches the personal disk that we found on the on like the live session of Fedora. The OS disk we'll use in a minute, but this is pretty much it, right? This is the minimum configuration that we need to get this working. And what I'm gonna do is I'm gonna create an atHomeHub controller file here, and I'm just gonna paste this for posterity's sake. Right, I'm just gonna keep this here, so separate from where we're actually dealing with the install and whatnot, just to make sure I don't lose it and keep track of the changes and whatever. Now we need to generate that ignition file that I was saying before. So I use Podman for this, so I can just copy that command and open a terminal window here. I can just paste it in here. Podman is an alternative to Docker. It does basically the same thing, only that Podman is just like open source and kind of better. If you use Docker, just do Docker run instead of Podman run, and don't specify this kind of colon Z here. Right, that one is something specific to Podman, I guess. Something with, say, Linux, and I can't remember what, but I just know you need it. But if we run, I haven't made this project public yet. 1 second. Okay, so sorry for that. I forgot to put the repository public. Right, it still has this lock. Ooh, that's a lot of zoom. Where is it? Lost it. There. So it still has that lock on it, and that's why we cannot really use it just like that. But by the time this video is out, I will make that public. I just forgot to do it before starting to film this. So as I was saying, we can just run this and then save the file and then run this. And that's going to give us 2 additional files in our data directory. So you have this Butane YAML, and this is basically a translation from that input file. So from these 17 lines here, we go to all this thing here, and this basically tells CoreOS how the operating system should behave. And this is more user-friendly, right? Like the Butane config is something that we have an easier time reading ourselves as humans, I guess. But this ignition JSON file is what's going to be used by the installer itself. So with those 2, we can just go ahead and download Fedora CoreOS. I should have done this before. But we're going to want the stable version. Let me make this like that, right? Stable version. And download the bare metal live DVD ISO. So that's going to get downloaded there in the background. And with that, we'll be able to run this other command. So let me just put this here in a file so we can take a closer look at what we're doing here. So we're leveraging this container image over here. All right, I'm guessing this is just a container image. Those are just some arguments we give it to it. So the CoreOS installer has an option to customize the ISO. So that's what we're doing. We're just running this ISO customize command. We're giving it our ignition file to use, the boot device to install CoreOS 2, the output ISO. So this is what we're going to actually like flash to our flash drive, I guess. And then this is going to be the downloaded CoreOS ISO file name. So let's just start filling in some of the details. So we said the OS disk is /dev/nvme0n1. So I'm just going to put it here without that, I guess. So /dev/nvme0n1. That's where we're going to do the install. And we need this file name from here, so that's still downloading. After it downloads, I'm just going to move it from downloads, so Fedora CoreOS. And I'm going to put it in this data directory where we have all the rest. We kind of need it to exist in that data directory. I'm just going to copy that and paste it here. And this is our final command, right? That's what we need to run in order to get the actual ISO that we'll use to install. So let's just give that a minute to do its thing. And that's it. It tells you that the boot media will automatically install to the device without confirmation. So you must be sure that you chose the correct device to install this with, because it will just install it. I've configured the installer to not wipe any partitions that might exist there. Right, that's why we started the wipe before, so we can kind of check on it and see what it's doing. And it's almost finished. This is completed, and this almost it's almost completed as well. So we did that to make sure that there is no partition there to cause any issues with the installer. And this is how your data directory should look like at the end, like when you have everything ready. So the input file that we talked about, the ignition and butane that were generated as part of that first podman command, the Fedora CoreOS ISO that we downloaded just now, and the server ISO that will kind of use a USB stick to install. So USB stick, let me just plug it in. First try. I use to flash stuff from Linux. I usually use something called Impression. It's been working fine, only that lately some of my applications no longer start on Linux, on Cosmic Epoch Alpha. It is my fault, right? I use a desktop environment that's in alpha, so I just need to deal with some of the issues that it comes with. And as a replacement for things like Impression, I just use like DD, which is very scary. Like the DD command can do so much damage. It's kind of insane. Oh, it opened. It took quite a while. Oh, but it doesn't. I am clicking. It doesn't want to do anything. So I'll just get rid of it, because I know it doesn't work. I've been dealing with it for quite a while. Give me a minute. Okay. You need to kill these processes at times to get them to stop, I guess. Linux things. So as I said, we'll use DD. So to use DD, first of all, you need to know the device that you're writing to. So /dev/sdg is my USB flash drive. I have no other flash drives associated with this machine. Like I have nothing else plugged into it. So I know that if it says it's a flash drive, this is the flash drive that I'm using. So I'm just going to do sudo dd. Input file is going to be data server ISO, and the output file is going to be /dev/sdg. My block size is going to be 1 megabyte, and I want to see the progress. So I'm going to say status equals progress. Review this many times. Just look at it, right? Spend some time looking at it. Just because if you get this output file device wrong, you're not like given any warning or anything, right? You just wipe whatever is there. So if you don't give the right one, it will wipe. Like you'll basically have the server ISO instead of like your games disk or your OS disk or whatever, right? So just make sure this is okay. Okay. So after stirring that for a bit, you can just hit enter. Should show a progress. It doesn't show progress. Was it progress equals status for DD? Status equals progress? Can't remember. But luckily for me, my USB drive has a light on it, so I can just physically look at it and I can see writes are happening to it. So I'm just gonna let it do its thing. And in the meantime, let's check on Fedora here. So this finished. I'm just gonna power it off. Power it off. And I did notice something when I was selecting the boot device before. Like I have a lot of records in the UEFI, like a lot of boot options there, and I don't want any of these, right? Like these free Fedoras are there for nothing. So I'm just gonna enter the BIOS, and under boot sequence, I'm just gonna kind of delete these. Get away. Okay. This finished writing, so now I can just unplug the device. And now we're just powering this off, plugging it in, power it, and let's press F12 for the boot menu. And we can see here the UEFI USB flash drive. That's the one that we're trying to install. I'm gonna just click on it, and I'm just gonna let it do its thing. Right, I could have pressed enter to kind of quicken it up, but yeah. Now we just wait and let it do its thing. And after it finishes, we're gonna remove the USB drive, and then it should automatically boot into the correct operating system. So let's just see. This is where the mistake with the boot device became apparent. So I didn't pay attention. I called it NVMe0 instead of NVMe0, and that failed the install process. So all I had to do was go back, rerun the second podman command, the one that generates the server ISO, rerun that with the correct destination device, flash the ISO to the USB drive again, and reinstalled the OS, and that was that. So it started installing. Right, we can see it says here installing Fedora CoreOS 42 whatever, and it's reading the disk and doing all that install. We can also check Unify, which kind of got locked out. So you can see atHomeHub controller, now it's 69.5, so it got the right IP address as we reserved it previously, so that's good. So once this starts up, we can just access it on that IP. All right, so the install finished, machine rebooted. I'll remove the USB stick from it, and let's see if it boots okay. At this point, I'm just not touching it. I'm letting it do its thing because I want this to be able to start automatically. It shouldn't need any input to start and just work. So that's why I'm not touching it and doing nothing to it. So let's see. The only place this could fail, as far as I've seen so far, right, like as part of my experimentations and tinkering with all this, is at this step, the ignition disk step. That's when it tries to create the file system on the second driver, the personal disk. And if we've configured something weirdly there, it will cause a failure. So if for some reason this fails, just try double check that your devices are specified correctly under the disks section of the config, and also check with the Fedora live install thing that your disk had no previous partitions on it. But it seems it has passed that, so now it's just kind of installing stuff and starting services. So we're just gonna let it do its thing. The first start, it's always gonna take longer just because it needs to fetch stuff and do things. Afterwards, it should be quicker. Let's see. And we can see here that we're greeted with this page. We see the IP address on the interface, right? We get the host name, the correct host name at this login prompt. So now I should be able to just start another terminal. Just do SSH core 192.168.69.5. And it's the first time we're SSH into it, so it's asking us to validate the fingerprint, and that's it. Right, we're landed in the shell of the box. Now, because it's the first time this starts, it might still be doing things in the background. What we need to do next is fetch the kubeconfig, which we can get with this command. So sudo cat etc rancher k3s YAML. This might return this, right? No such file or directory. This would happen if the kind of first start of Kubernetes is still kind of trying to set everything up on the machine. So just give it a bit of time, or maybe a minute or two, and it should show up. We can also do a sudo or just an ls in that directory. So rancher k3s, and we can also start the watch on this. So we can just wait for that to show up, and it just showed up. So now we can do the cat command again, and this is our kubeconfig. Back. So this is similar to your private key, right? This cannot leave your machine, right, or your hands. Nobody else should know about this. I'm only sharing this because this is a dedicated cluster that I have for this like video series. I am just gonna delete it and recreate it, and whatever is gonna be different. But you must protect this file, right? It must not leave your machine, and no one else must have access to it, because this grants admin access to your cluster where all your files and where everything is going to live. So you don't want that to, you don't want someone untrusted to have access to your stuff, right? It's like anything secure. Now, in order to use this, we need to put it in a .cube directory in your home. So because I already have one, I'm just going to move it in a different name. So I'm just going to do .cube mine. So now I don't have this .cube directory. So I can just create it, .cube. And then I'm just going to open a .cube config file. This file doesn't exist, but when I do the Z thing, and you can do the same thing with like code, it's gonna just create a file, right? And then you can just save your stuff there. But if we try to use it now, right, like we put this here, now we can interact with the cluster using the kubectl command. So if we do like a kubectl get nodes, it's going to fail because we haven't set some stuff. So for example, it's trying to connect to localhost, which might have been fine on the machine, but on the network that is present on this IP address over here, right, 192.168.16.9.5. So I'm just going to change this here. And now when I do kubectl get nodes, I actually have a response, right? I have the atHomeHub controller node. It's not ready. That's expected. And it has the control plane role, and it's like 2 minutes old, right, with this version of Kubernetes. So that's fine. Something else I like to do is just change this default here. This is a YAML file, right? So you can make it look a bit prettier by changing it to YAML. I usually change this just because I have more clusters to deal with. So this can be the atHomeHub cluster, and that would make it more obvious in case you have multiple clusters, multiple contexts, and multiple users here. So that's just something to do. I also made notes of it here. I guess I made note of changing the IP address, but it is okay. All right, and that's it. Right now we can just power off the machine. To power off the machine, I usually just going to press the power button. And it's going to trigger a power off sequence on these. Right, you can just do sudo power off from the terminal, but this is usually easier. And I'm going to put this in its final resting place. And then we're going to deal with the second node, right? The worker node. So just give me 1 second. So I put this in its final resting place, and I started it off. So now if we can ping it to see when it becomes alive. Right, so it's going to take a bit of time to boot. Hopefully it's not going to have any issues, but we see a response from it. So if we try to get the nodes again, we just get the nodes. So, great. All right, it started off, that's okay. Now let's deal with the worker. Same as before, boot into Fedora. Okay. So now we're going to do exactly the same thing as we've done so far, with some minor changes. We'll talk about those when we get to them. But I'm going to do like the same investigative work as we did before, right? I'm going to find the disks that I'm going to use, the IP address, assign it to a static IP, take note of all these, and then we're going to deal with the input file. So I talked too much about setting up the worker, and that wasn't really necessary as the process is pretty much the same. All I did for the worker was to take the example worker file from the repo, change the worker's name, made it atHomeHub worker1. I added the 1 at the end just in case I want to add more of them later down the line. It's just easier to increment a number than to give these a different name. And then as part of the configuration, the main differences between the worker and the control plane is the K3s role. That changes to worker instead of control plane. And then you have the worker-specific properties, which are the cluster address, which needs to point to the control plane, the one that we installed earlier, and the node token that we have to fetch from the control plane itself. There's a command for that in the repo, so we can just run that, and it returns the token. We also give the workers an additional purpose in the node purposes list. We set this to general, which is used for all applications. And in the future, we'll add more purposes to our workers depending on what we're installing them for. You can think about like media specific workers or things like that. After that was done, right after we've configured that, I basically followed the same process, right? Generated the ignition file, created the ISO, flashed it to a USB drive, installed it on the machine, and then it started, and after a few minutes I saw it join the cluster, and that was that. So that's pretty much it, right? That's kind of bootstrapping the Kubernetes cluster, right? That's how we can do it as part of this project. And we have the control plane, right? We have our worker, so they're both ready to start installing stuff. I mean, they're not ready. We'll address this in the next video, right? Getting these ready and actually start installing stuff. So I did forget to say one thing, right? We put these files in this kind of local directory on our machine. We define these files over here. And we should also take note of the IP, just so we remember that. We can commit these now. So we can stage all these changes, right? We basically created this, and we can see that this is like the initial commit. We can just commit them. And again, we're just committing them to our local repository. We're not actually publishing them anywhere. So now if we were to make a change, that's going to get highlighted, and then let's say maybe not that change, but let's say we would add another key. We can make that change, and then we can commit it and just say add additional SSH key or whatever. I'm not going to commit this just because this isn't a change I want to make. But that's why we did that git init command at the beginning, and why we're working like this basically. So yeah, don't forget to commit your changes. In about an hour, I was able to get this cluster started, right? Like this cluster bootstrapped and running and ready to install stuff on it. So I think all in all, it's not that difficult to do all this. Of course, I do know what I'm doing, and I did spend time kind of explaining, so you could be quicker at this or even slower, but it doesn't really matter. It's just, let's say, a few hours worth of effort, and you can bootstrap this and have just a cluster ready to install stuff on it. And yeah, I think that's about it. As I said, in the next videos we'll start doing installing stuff in it, and yeah, I guess I just need to stop talking. Thank you for watching. I'll see you in the next one.